So, good evening, everyone. Welcome back again to the session of quadratic equations. I hope you have gone through the first three videos where we have discussed more about the introduction. Then we went ahead and then we saw the relation between the roots and the coefficients. And then further we went to the difference of roots. And then yesterday session I gave you a task that you try to figure out that is it possible to reduce a polynomial given in terms of alpha, where alpha is the root of a quadratic, let's say x squared plus bx plus c. So this expression, the polynomial in terms of alpha of higher degree, can be reduced to a linear expression, or I can say a linear polynomial. I hope you would have done some sort of research either through Google or trying out with some books or study materials. So let us do this. This is what we have, that we said that, let's say alpha is a root, or let's take that question itself. Let's say that alpha is a root of x squared plus 3x plus 5 equals 0. Okay, so let me rewrite it. Let's say that let alpha be the root of x square plus 3x plus 5 equals 0, and we are saying that this alpha to the power 4 plus 3 alpha square plus 2 alpha minus 5 is going to be equal to a alpha plus b. So our target is to find the value of a and b. Okay. Now one thought could be, or line of thinking could be, is that if alpha is the root of this given equation, can I write that alpha square plus 3 alpha plus 5 equals 0? I mean, if alpha is the root, obviously it will satisfy its equation. So what is alpha square? So alpha square you will be getting minus 3 alpha minus 5, right? Then I can see there is a alpha to the power 4, isn't it? So how to generate this alpha to the power 4? So simple thing, you can square it. So when you square both the sides, you got alpha square square equals to negative of 3 alpha minus 5 whole square. So left hand side we got alpha power 4, right side we got like a 9 alpha square plus 25 and then plus 30 alpha. Now again you can see like alpha square can be written in terms of alpha, isn't it? So let us feed this value over here. So what is alpha power 4? It is 9 times minus 3 alpha minus 5 plus 25 and plus 30 alpha. So when you try to evaluate, it is minus 27 alpha minus 45 plus 25 and plus 30 alpha. So when you further simplify this, what are you getting? 30 and 27 will compensate and will give you 3 alpha, and minus 45 and 25 will give you negative of 20. Now since there is no alpha cube involved here, there is no need to calculate, but in case the question would have alpha cube term also, so then what we will do? We got alpha square, you multiply alpha both the sides, the left hand side will become alpha cube, right side you will be getting alpha square and alpha term, isn't it? That alpha square again you can replace with minus 3 alpha minus 5. So ultimately what you will get is, you will get a linear expression. See, the point here is simple. You got alpha square in terms of linear, isn't it? Now suppose you want alpha cube. So what you can do? Multiply both the side by alpha. So left side will be alpha cube, right side will be alpha square term, and some alpha and some constant. That alpha square again you replace with a linear, which is minus 3 alpha minus 5. And ultimately after all cancellations and all, you'll get a simple expression. If suppose alpha to the power 10 is there, so what we can do? See, like this alpha square, you multiply one time, alpha cube will come, that you can reduce to linear. Then alpha cube, you can multiply with another alpha cube, right? So alpha power 6 will be generated. What right side you'll be getting? Again a linear into linear, a quadratic will come. That quadratic you can further reduce into linear. So point here is that whatever the higher powers are there, we will be always able to reduce it into a linear expression using the fact that alpha is a root of the given quadratic. Okay. So now let's get back to this question. Alpha to the power 4 value we can feed, which is 3 alpha minus 20 plus 3 times alpha square value we can feed, which is minus 3 alpha minus 5 plus 2 alpha minus 5. So when you simplify this, it is like 3 alpha minus 20 minus 9 alpha minus 15 plus 2 alpha minus 5. Okay. So when you simplify this, these guys are of similar type, 3 alpha, this and this. So final calculation is 3 to 5 minus 9 is minus 4 alpha and minus 20 minus 15 and minus 5 gives you minus 40, which we can write like negative of 4 alpha plus 5. So what is A value? A is going to be minus 4 and what is B value? Minus 40. Okay. So this is one of the way to handle this problem, right? Now the question comes that if in case more higher powers are involved, let's say alpha to the power 6, alpha to the power 10, or more and more higher powers are involved, in that situation do we have to follow this? Because definitely some important time of our life will get consumed in evaluating the higher powers, isn't it? Suppose tomorrow somebody comes and gives you calculate what is the value of alpha to the power 100 plus 3 alpha square plus 5. So are you really going to calculate alpha to the power 100? So we are here to do some smart work, not the only hard work. Right? So we'll not be going with that method. So what is the alternate? The alternate method is alternate. See, you wanted to calculate alpha to the power 4 plus 3 alpha square plus 2 alpha minus 5. What is the first and foremost thing you do? Definitely you would be knowing long division method, isn't it? So let us divide this given expression with with the left hand side. Left hand side means that alpha square plus 3 alpha plus 5. Was it? So we have alpha square plus 3 alpha plus 5. Do the long division. So we'll go alpha square times alpha power 4 plus 3 alpha cube plus 5 alpha square. So when we do the calculation, negative, negative, negative. So what we got? This will get cancelled. This will get cancelled. And then we'll be getting minus 3 alpha cube. 3 alpha square minus 5 alpha square will give you a negative of 2 alpha square. And then there is 2 alpha. So now we can go with a minus 3 alpha. Right? So what we'll be getting? We will get minus 3 alpha cube minus 9 alpha square and minus 15 alpha. Again what we will be getting here? So plus plus plus, this part we can cancel, and we got something like 7 alpha square, then 17 alpha minus 5. So we can go 7 times. This will be like 7 alpha square plus 21 alpha and plus 35. So when we go for the subtraction this time, you can see like this gets cancelled, and ultimately we have got minus 4 alpha minus 40. Now I'm sure your eyes would be glittering that you can see this is exactly the same quantity that we have got above, isn't it? Okay. Now how to conclude that this is the answer? So in childhood you would have learned something like that dividend equals divisor into quotient plus remainder, isn't it? Even in your polynomial 9th standard and 10th standard you would have learned this, isn't it? That a given polynomial can be written as divisor into quotient plus remainder, isn't it? So in this case, what can we write? We can write alpha to the power 4 plus 3 alpha square plus 2 alpha minus 5 equals alpha square plus 3 alpha plus 5 multiplied by alpha square minus 3 alpha plus 7 and plus the remainder. The remainder. Let me just create some space. So what is the remainder? The remainder is minus 4 alpha minus 1. Right? Let us write in some different color. Now you know already that this quantity is equal to 0, isn't it? Because alpha is a root. So when you substitute here 0, what will happen? This entire expression will become equal to 0, right? So ultimately what we will get, alpha to the power 4 plus 3 alpha square plus 2 alpha minus 5 can be written as minus 4 alpha minus 10. And when we can write? When we know that alpha square plus 3 alpha plus 5 is equal to 0. Right? So I hope you'll be clear with this method. Right? Now, in case if it is in the class, definitely I would have asked that, do you have any doubts? So mostly the students don't catch this up. So then my question would be to all of you is, can we divide by 0? Because we are saying that alpha square plus 3 alpha plus 5 equals 0, isn't it? And you are doing a division by 0. You are doing a division by 0. Is it acceptable? I hope you are getting my question. See, the first part is we did the long division, isn't it? So we did long division. We got the value. That's completely fine. And we got our answer also. Very comfortable, and it will work. It will work always. But I'm just trying to put a doubt in your mind that alpha square plus 3 alpha plus 5 equals 0, isn't it? And then you divided a polynomial by 0 and you got a required quotient also and remainder also. How do you justify this? So this I'm leaving it up to you. Again, you do some sort of research. Everything should not be served on the plate. So please make sure, try to find out that whether what we have done here is right or wrong. One thing I can assure, that it will work always and it will give you the required answer. Okay. So let us, I hope the method we are comfortable with. Right. So let us take one example related to this topic and how it can be used in the quadratic. So let's say the question is let alpha comma beta be the roots of x square plus 3x plus 5 equals 0. Then form a quadratic equation with roots as alpha to the power 4 plus 3 alpha square plus 2 alpha plus 5 alpha minus 5 comma beta to the power 4 plus 3 beta square plus 2 beta minus 5. So this is our question. The question is what? That alpha and beta are the roots of a given quadratic. So you are supposed to figure out a quadratic equation whose roots are alpha to the power 4 plus 3 alpha square plus 2 alpha minus 5 and this. So I hope those who would be very much courageous will take the approach like, okay, I will try to find what is the sum of the roots. So he or she will give a try to calculate alpha to the power 4 plus 3 alpha square plus 2 alpha minus 5 plus beta square plus 2 beta 3 beta square plus 2 beta minus 5. So first you will give a try to calculate the sum of the roots. Then in case still some courage is left, so then you will go for the product, like let us multiply one by one and then you do the evaluation. So I hope by now you realize that the normal methods that we use to find the quadratic equation with the given roots, like finding the sum of the roots and product of the roots, and using the fact that the equation would be given by x square minus a times x square minus sum of the roots times x plus product of the root equals 0, right? Okay, so I hope you realize that that method is going to be slightly difficult, and in case if there is one or two students who is like, no sir, I will definitely pick it. So to handle them, what I will do is I will increase this power 4 as some 2004, not 2004, maybe let's slightly increase it. We can make it, let's say 14, or we can make it 8. So then whatever little bit of energy was there, I'm sure that it will get exhausted. So let us see how the previous topic that we have discussed can be helpful. So we know just now, you can see smartly that related to the previous question only I have taken the equation as well as the roots, isn't it? So we can use the previous information, right? If it is a new question, you have to repeat the entire process of the previous question. So when we go to the solution, what we can write? We know that we know that alpha to the power 4 plus 3 alpha square plus 2 alpha minus 5 is actually equal to minus 4 alpha minus 40, right? And similarly, so beta power 4 plus 3 beta square plus 2 beta minus 5 is going to be equal to minus 4 beta minus 4, right? So instead of adding these guys, it is more easy to add these guys, isn't it? So if I try to find the sum of the roots, sum of roots, I can write what? Minus 4 alpha minus 40 minus 4 beta minus 40, which can be written as negative of negative of 4 times alpha plus beta and minus 8. What is alpha plus beta from this equation? So we know that alpha plus beta is minus 3. So this minus 3 we can feed here. So we'll be getting 12 and minus 80. So what we got? Minus 4 into minus 3 minus 80, which will give us 12 and 80. Which 68, 68 into 70, 80. Yeah. So we'll get minus 60. Similarly, when we try to calculate the product of root, so it will be like minus 4 alpha minus 40 multiplied by minus 4 beta minus 40. So ultimately what we will get? We will get 16 alpha beta minus, not minus, because see both the brackets are having minus, you can just take out and you can intact the positivity in this question as well as in life. So we got 16 alpha beta, and then what next? You will be getting like 160 times alpha plus beta, and then you'll be getting 1600. Hope I am correct. 4 alpha into 40 will get 160. So then again, simple thing. What is alpha into beta? Again, so from here again, alpha into beta is 5. So you can just feed the value 16 into 5 plus 160 into alpha plus beta is minus 3 and plus 1600. So you got 80 minus 480 and plus 1600. You can see that 80 and minus 480 will compensate and will give you a negative of 400, and plus 1600 will give you in total 1200. So our quadratic is going to be x square minus sum of the roots, which is 68, plus 68x, and then product 1200 equals 0. So this is the required solution, right? So imagine in case if somebody goes with the longer approach, almost a lot of time will get consumed, isn't it? So again I'm repeating that you have to find the smart ways to solve the problems rather than the hard ways to do the problem. Okay. So I hope you are clear with this topic. Just see once, have a glance. right? So we can write a note point here after discussing all the things above. Note what it is. It says that if alpha is a root, if alpha is a root of quadratic equation ax square plus bx plus c equals 0, and when I mentioned quadratic equation, it is very well understood that a should not be equal to 0, then any then any polynomial expression in alpha, any polynomial expression in alpha can be can be reduced can be reduced into can be reduced to linear expression linear expression in alpha in alpha. Right. So I hope you are comfortable with this. Okay. So now let's go to the next topic. You can write it as another. Now see here, basically what we have discussed so far is that the introduction we discussed, then we related the roots and the coefficients, then we discussed the difference of the roots, and now we have seen like the evaluation of the quantities which are symmetric in alpha and beta, like finding the value of the expression symmetric in alpha and beta. Then we discussed that any polynomial expression in terms of alpha and beta can be reduced to a linear expression. Now the next topic that we are going to discuss is, imagine somebody comes and just tells you that ax square plus bx plus c equals 0. They have mentioned only this, that ax square plus bx plus c equals 0. Ax square plus bx plus c equals 0. How shall we approach in solving this question? So normally when I put up this question in the class, then the student starts answering x equals plus minus, then minus b plus minus root under b square minus 4ac by 2a. Okay. But the question is it the only solution? Or are we missing out anything? So if you go back and see the video again, you can see like very smartly I have just only mentioned that ax square plus bx plus c equals 0. I did not use the word quadratic equation. Right? So when I don't mention quadratic equation, it means that there is a possibility that a can be equal to 0. Right? So whenever in a question they don't use the word quadratic equation, right? This quadratic word is missing. In that situation, when we are trying to solve, we should solve two cases. Case one, when a is not equal to 0. So when a is not equal to 0, whatever we have learned in quadratic, that information can be utilized. In case, and the second case would be that a is equal to 0, and then we will try to proceed. I hope you can get the point what I'm trying to convey. So let us write it. Please write. The first point, if the expression, if the expression ax square plus bx plus C, where A comma B comma C are are constants, is not referred not referred as quadratic, is not referred as quadratic, then we should we should analyze analyze both cases. What are the cases? Case 1, A not equal to 0. Case 2, A equals to 0. What I mean? Just a minute. I'll just highlight the things, the important things. Okay. Simple thing is, if you see, like, when expression, when you're reading the question, and when you see expression like x square plus bx plus c and which is equal to 0, don't directly jump to the conclusion that it is a quadratic and you start solving. Okay, so you see whether the quadratic word is missing or is there or it's not there. If it is not there, then you have to solve both the cases. Okay. In case it is mentioned, then be happy, go ahead by treating it as a quadratic and solve. Okay, now let us write the second point. The second point is, if ax square plus bx plus c equals 0 is satisfied is satisfied for more than two distinct values of x given a comma b comma c are are constants are constants means what I have written so far, that if ax square plus bx plus c equals 0, this equation is getting satisfied for more than two distinct values of x. Let's say this expression is satisfied for x equals 1, 2, 3, right, or 1 minus 1, 5, like more than two values, right? Then what is the conclusion? Then a equals b equals c equals 0, and it is an identity. It is an identity, and it is true for all x. Let me again highlight the important part. If this satisfied for more than two distinct values of x, then this, it is an identity. So you can say, like, you could have written in red itself. So I'm just highlighting it so that when you are referring the notes, it will come to your eye directly. What we are saying, first part, you can see, like, very smartly in this whole statement there is nothing written like quadratic. There is nothing written like quadratic, because the moment I mention quadratic, it will be bounded. We are bound to say that it will have how many roots? It will have not be three. It has how many roots? Two roots. Okay. Now, so I have not mentioned quadratic. So I'm just talking about the equation which is of the form ax square plus bx plus c equals 0. Now, if it is satisfied for more than two distinct values, right? So what we are telling, if it is satisfying, but it is getting satisfied by more than two values, then all the coefficients a, b, c, all three of them are going to be equal to 0, and basically it is going to be an identity. It means why abc equals 0, that I will discuss, but first let me conclude the conclusion part. See, if a becomes 0, b becomes 0, c becomes 0, isn't it? Now whatever x you bring, 5 minus 5 2 1 by 2 0.3 minus 0.7 whatever you bring, what will happen? 0 into something square, that number square, plus 0 into that number, and plus 0. So ultimately what you will get? You will get 0 equals 0, isn't it? So what is big in this? Isn't it? So if A, B, C becomes 0, then what will happen? This is going to be an identity and it will be true for all the values of x. Now the question comes. I hope we are comfortable on this. The conclusion part. Okay. I just quickly repeat. If ABC becomes 0, basically your left hand side expression you see is like 0 into something square, 0 into something plus 0. You keep substituting x values. 0 is in multiplication. It will ensure that it makes the entire thing as 0. So left hand side is 0, right side is 0. Equal to is intact, and both the parties are happy. Now let us come to the conclusion that why ABC should be 0. Imagine that if ABC is not 0, okay, right? Let us say that neither A nor B nor C is 0. In that situation, it will become a quadratic, or let us say that A is not 0. If A is not 0, it will become a quadratic, and a quadratic equation can have how many roots? It can have maximum 2 roots. But how many roots you are having? You are having 3 roots. So I hope you can see the contradiction. If it becomes a quadratic, where A is not equal to 0, you are supposed to get only 2 roots, isn't it? Because if it is not, whatever discussion we have done, although my efforts will go in waste, isn't it? So that's not the case basically. Still, a quadratic has only 2 roots. So, but you are getting 3 roots. It means what? It means what? That A is bound to be 0. Now somebody will say that, okay, let us say that B is not 0. If B is not 0, then you will get a linear expression. A linear expression has how many roots? One root, right? But you are having more than 2 roots, right? So because of that, what happens? When A should be 0, B should be 0, and C should be 0. And then it is an identity which is going to be true for all the values of x. I hope you are comfortable on this. Okay. So let us do a question on from this topic. So I can just highlight this. Quadratic is not used. What I mean here? I mean here is that very smartly nowhere I have not used the word quadratic. So from now onwards, the moment you see something like ax square plus bx plus c equals 0, don't start jumping it is quadratic. You see whether they have mentioned quadratic or not. If not, then accordingly we have to analyze the cases, right? So let us see a very quick question. Let's say the question is, okay, find the value of k for which the equation in variable x. What is the equation? So let us say it is a square minus x, sorry, a square minus a minus 6 times x square minus, just a minute, let us say it is plus a square plus a minus 6, and let us say it is a square minus 2a times x and plus a square minus 4 equals 0. Yeah. A square plus a minus 6 times x square minus a square minus 2a times x plus a square minus 4 equals 0 as more than more than 2 roots. So what is the question? The question is that there is an equation which is in terms of x and there is a parameter a. So okay, I have mentioned p, right? So we can do the required changes. Let us say it is k. Here it is k. This is k. Let's do the other way. In place of k, let's say it is a. Find the value of a for which the equation in variable x, a square plus a minus x minus a square minus 2a times x plus a square minus 4 equals 0 has more than 2 roots. It has more than 2 roots. How to approach this? So again, you can pause the video, you can give it a try, and then you can come back and you can check your answer. So let me solve here. Say simple thing. The degree is 2. So if it was quadratic, you can see that the quadratic word is not used. It should have exactly 2 roots. But they are asking that it has more than 2 roots. So basically what should happen? It should be an identity. It should be an identity. So what I can write, since given equation has more than 2 roots, more than 2 roots, it is an identity. It is an identity. Therefore, a square plus a minus 6 equals a square minus 2a equals a square minus 4 equals 0. So from here, what are the values we'll get? We'll get a square equals 2 and minus 3. From here we will get a equals 0 and 2. And from here we will get a equals 2 and minus 2. So here the catch is, again my question, you answer it wherever you are. Is the answer a equals 2, minus 3, 0, 2, 2 and minus 2? That all the values are possible or only one value is possible? So let me repeat, the necessary condition is that each one of them should be 0 simultaneously. So you see, like when each three of them are 0, right? So they are 0 at a equals. So the required answer is a equals. I hope you are clear. So let us see another question. Let's say the question is prove that x minus a into x minus b divided by c minus a into c minus b into c plus x minus b into x minus c divided by a minus b into a minus c into a plus x minus a into x minus c divided by b minus a into b minus c into b is identically equal to x. What is the question? Question is a proof that left hand side is equal to right hand side. What is on the left hand side? Left hand side you can see some 2-degree expression is written in the numerator, denominator, some constants are there. And here again the middle term, like kind of symmetry you can see, like the terms the way it is written. Numerator 2 brackets are there, denominator 2 brackets are there, numerator some variable x is involved, denominator only constants are there, isn't it? So the question comes over here is prove that it is identically equal to x. So again For today. Stopping the video over here. Please solve this question and again come back to check the process that you have followed and the process by which I am going to solve. Right? Are they same? In case you are having a better method, then please let me know. So let us see you guys in the next video. Till then, please keep revising, keep solving some problems from your sources, either some textbooks or package or study materials, whatever you have. Fine then. See you. Take care. Thank you. Bye bye.